And then we've got example 13. Again, we're told the substitution. So this is fairly routine, actually, to some extent. I think this one's easier a little bit. So we know that u is sine x plus 1. And as a result, du by dx equals cos x. And one thing that's slightly different here is, instead of saying what dx equals, it's actually slightly more useful to notice that du equals cos x dx, because cos x dx is actually in our question. Obviously, we're multiplying all of these terms together, so I can reorganize them if I want. So I have a cos x dx in my integral, which I can just replace, therefore, with du. So that's quite handy. So the 1 plus sine x, that's no problem, I've got that here. The cos x and the dx, I've got them here. I also need to replace my sine x. So it's just helpful here to note down that sine x is going to be u minus 1. I'm ready to do my substitution. So my integral is now going to be, I'm going to replace the sine x with u minus 1. I'm going to replace the 1 plus sine x with u, which is cubed. I'm going to replace the cos x dx with du. And at this point, expanding those brackets out would be sensible. So that's an integral of u to the 4 minus u cubed du. And from here, it's a pretty straightforward thing to integrate. So that's going to be u to the 5 over 5 minus u to the 4 over 4 plus some constant. And the final step is to replace the u's with my sine x plus 1. Go back to O over 4. So I have sine x plus 1 to the power 5 over 5 minus sine x plus 1 to the power 4 over 4 plus my constant. And I'm done. I've got it back into terms of x. Again, if you really wanted to, you could do some more work on this. You could join the fractions together. You could do some expanding. There's absolutely no need to. Once you have something in a form that is in terms of x, you don't need to go any further. And it's rare that you'd end up with anything you could tidy up with much anyway.